Okay, example 3. Now the first thing I would do is draw a sample triangle. That might be what we're looking at. Now bear in mind, there are going to be some where no triangle results. There's going to be some where 2 triangles result. So your triangle may not be the triangle that you find, but it at least gets us going on it. It also helps us when the letters are exchanged or changed up. So whether they rearrange the A's, B's, and C's, or they use letters like H, J, and K, or something like that. So what I always do is I always take one of the angles I'm given, angle A in this case, put it down the bottom. Then I take the side that I'm given that's next to angle A, that's B, I put that here, B is 12, and A is always going to go across. So in this case here, the letters A, B, and A match up with the diagram we just saw previously. So first of all, since I noticed that A is greater than B, then we have that fourth case that we have only one triangle. I don't actually, in all honesty, remember saying that fourth case, but the idea here would be this, that we have our height, and all of those cases, whether they were 0, 1, or 2, all depended on A being less than B. But if A is greater than B, then there is no way for this side to come in here because it's 12 units or inches in this case from this point down to A. So the only way to do it would be for A to go out from the height and form a triangle this way here. So when A is greater than B, we have one triangle. So let's go ahead and do that. So we're going to go ahead and I'm going to label this angle B. I'm going to label this side C and up here angle C. So the first thing is I have a side angle combination. So I'm going to go 22 over the sine of A equals, and we're going to go B, which is 12, over the sine of B. We're going to cross multiply. So 22 times the sine of B equals 12 times the sine of A, which is 42. So the sine of B dividing both sides by 22 gives us 12 sine of 42 divided by 22. And now we have to get rid of the sine in front of the B. To do that, we use the inverse sign, which will cancel out the sign that we have here. So B is equal to the sine inverse of 12 sine of 42 over 22. So B equals, let's go to our calculator and we will take a look at that. So first thing we do is we hit the sine inverse. At this point, if you want to go ahead and create a fraction, alpha y equals option number 1 gives us a triangle. I can type 12 times the sine of 42, close that, go down to the bottom, 22. Again, we don't need to do the parentheses, but you can if you want. And we get 21.4 degrees. From here, given 2 triangles, we're going to go ahead and find triangle C, or angle C, by subtracting 42 plus 21.4 from 180. That gives us 116.6 degrees. And then finally, still using that 22 over sine of 42 equals C over the sine of 116.6. Just 1 second. So C comes out to be 29.4 inches. Okay. Now it wouldn't be bad at the end. I don't do this all of the time, but it wouldn't be bad at the end to just state like everything. So A is 42, B is 21.4, C is 116.6, A is 22, B is 12, and C is 29.4. It just makes it nice and easy to see the comparison that B is the smallest angle and side, A is the middle angle inside, C is the largest angle inside, and it's just a nice view of the answer. All right, let's move on to the next example. Again, just sketching real quick just to get an idea and then get kind of a placement of everything. So A is 85, B is 25, and A is 15. So again, because A is less than B, I'm immediately going to find H, which is, again, it's this corner, so it's B times the sine of A. So it's 25 times the sine of 85, and that comes out to be 24.9. So again, what that means is it's 24.9 units from this end of B down to this side here. So if A is only 15, there's absolutely no way for that 15 inches or centimeters or whatever units we're using to reach all the way down. So since A is less than H, no triangle results. So even though I drew a triangle and threw these numbers on, there actually is no triangle with those dimensions. All right. Final example with the ambiguous case. This will show us our two cases. Again, same situation as before, except the letters and the variables have been changed a little bit. So that whole A sine of B is not, or B sine of A is not going to work for us here. That's why it's most important for us to understand the concept. So angle B, I'm still putting in the bottom corner. A is now this side over here, and B is across from it over here. So it's these two pieces, the 31 and the 20.5. All right, so again, B is less than A. So the side that's across is smaller than the side that's adjacent to the angle. So then we progress to the height. Height in this case is A times the sine of B, so it's 31 times the sine of 20.5. And that comes out to be 10.9. Since B is greater than H, we have two triangles that result. So we call them case 1 and case 2. You can call it triangle 1, triangle 2. It's not super important for that. So again, this information is consistent. What's going to change is this angle that's down here as well as this angle up here. All right. So again, we have only one choice of direction to go. We have to find angle A. So we're going to go B. So that's 12 over the sine of 20.5 equals 31 over the sine of angle A. For time's sake, I'm going to trust that you can cross multiply and solve. What you should get in this case is that A comes out to be 64.8 degrees. If you go back in that video to look at the ambiguous case, that's that bottom right angle of that isosceles triangle. So the other angle A for the second case is going to be 180 minus 64.8, and that comes out to be 115.2. So now we have the beginnings of our two triangles. The only thing left is to find angle C and side C. I'm going to leave that for you to figure out. Again, you already got two angles, so finding the third angle is no problem. And then we'll use that third angle to find the law of, or to find that third side by using the law of sines. Okay. Just for reference sake, I will give you C is 94.7 here, and side C is 34.2. Up here, angle C is 44.3, and side C is 23.9. This is degrees. All right, one last video dealing with the area of oblique triangles, and then I'll have you get started on the law of sines homework.